All right, welcome to the first lesson of quarter 2. This is week 1, lesson 1. I'm going to, hopefully you've downloaded these notes, and if not, you can just follow along and download later. Again, you can always refer back to this video and rewatch as needed. So first thing we need to talk about just a little bit is some of the notation. So you are probably used to this notation for a line segment, but the textbook that we're using uses this for the notation of a line segment, and the difference is just the United States versus Europe. Again, like we use miles, they use kilometers, we use inches, they use meters. It's just a difference. Get used to it. All right, next, do you already know this notation as far as a ray? I just want to make sure you know that. It's the exact same notation that we are going to be using for vectors. And then this is probably the most important. Ray AB, or even if I called it vector AB, is not the same as BA, all right? They are directed line segments. In fact, if you look at this first example we're going to do, that's what we're going to call it, directed line segments. So if you have this parallelogram, I can speak, I swear. They want you, or actually I would like you, to find all the equivalent directed line segments. So let's just pick a line segment. Okay, so I'm going to pick PS, which I probably should not have picked blue because you can't see it. Here we go. So PS as a directed line segment is completely congruent to this line segment, QR. All right, now, I want you to see that that is different than SP, right? SP goes in this direction, which is equivalent to a completely different directed line segment over here. It is RQ. All right, now there are two others that are directed. If I went from S towards R, that is equivalent to PQ. But if I switch it around, if I go in the other direction, again, these are directed line segments, it wouldn't be PQ, it would be QP.
Go by the name of vector. It's a mathematical term, a quantity represented by an arrow with both direction and magnitude. Vector! That's me, because I'm committing crimes with both direction and magnitude. Oh, yeah!
All right, scooting it up. This is the definition of a vector. You just heard vector say that. So let's take a look at example 2. It says, again, you can read, but I'm asking you to draw 4 equivalent vectors, meaning it has to be the exact same length and it has to point in the exact same direction. All right, so you could draw them anywhere as long as they go, and it looks like it's going 2 to the right and 3, 4 down. So let's say I start here. 1, 2, 1, 2, 3, 4. This is equivalent. It's the exact same vector. That is the thing about vectors. Where they start and where they end, 1, 2, 3, 4, doesn't matter as long as they have the same direction and the same magnitude. 1, 2, 3, 4. All right, again, I can draw this all day long, but every one of these is considered to be the same. If I labeled this one A, then this is also A, and this is A, and this is A, and this is A. All right, now what if I drew this? 1, 2, 3, 4, 1. If I drew this, any guesses what I might call that? And you're absolutely right, that is negative A. All right, so it has the exact same, the opposite direction, but the same magnitude. All right, next we need to talk a little bit about notation, about some different ways that you might see this. These are all completely interchangeable. You may see this in boldface, meaning this should be a lot bolder. I couldn't get it to print right, but just pretend that's really, really, really bold. Okay, you may see it with the arrow on top of a single lowercase letter, or you may see it looking like a ray. This one's probably the one that will get used the most often. Really important that you understand that this part at the end of the arrow is called the tail, and this end that has the actual arrow over it, all right, I like to think of that as its hat. That's how I remember that this is considered to be the head. There's the tail of the vector and the head of the vector. All right, again, we're kind of reading this. I already talked about this a little bit. Vector AB is the opposite of vector BA. Okay, moving this up, let's talk about how we're going to add these vectors, or any vectors. All right. Method 1 is the method that is used more by physics teachers. And here's why. So let's say you had some sort of an object sitting here at point A, and there were two different forces being acted on it, right? So maybe the wind is blowing and you're blowing, and I don't know, there's a hill. So it wants to go downhill, but because you're blowing on it, it's not going to go straight down the hill. It's going to go off in this diagonal direction. All right. So what this picture is trying to show you is that vector AB plus vector AD would result in vector AC. Now, from that last example where I said all those vectors were perfectly equivalent, AD is actually the exact same thing as BC. Those are the same. So that's where this formula down here is coming from. But probably most important, right? So method 2, which is the way I'm going to have you do almost all these problems, this is sort of more the mathematical way. And what I really want you to see, let me erase some of these lines here, give me a sec. I want you to see that when you are adding vectors, you have to add them head to tail. This is the head of vector AB, but this is the tail of vector BC, and that your result, your final answer here, is vector AC, right? It's the tail of the first and the head of the last. So when you add vector AB to vector BC, the answer is vector AC. All right, moving this up, we're going to try some of these on graph paper so that they come out nice and accurate. I'm going to attempt to draw straight lines using a straight edge on my iPad. That's how I make these videos. If it comes out kind of funky, please be forgiving. I'm doing the very best I can. So on this example, I need to add AB to CD to EF. So in that order, I need to draw those from head to tail. So AB looks like it's 4 units to the right. 1, 2, 3, 4. That's AB. Next, I'm going to add CD, right, where I'm going to connect the tail to the head. So I'm going to go over 1 and up 3. It looks something like that. That would be CD. And then I have to add to that EF, which seems to kind of go backwards this way, up 2 and to the left 2. So again, adding head to tail, head to tail, head to tail. My result, my answer, it doesn't want to draw okay, I can't do it with a ruler, or at least not a metal ruler, which is what I have. This resultant vector is my answer. Now keep in mind I can draw that anywhere. It looks like it goes over 1, 2, 3, 1, 2, 3, I lost it. 1, 2, 3, 4, 5. 1, 2, 3, 1, 2, 3, 4, 5. This is the answer to that problem, right? That one vector. And again, you could draw that anywhere, right? Anywhere at all. All right, and this is the last example for your very first lesson of quarter 2. If I've given you vector A and vector B in this picture, they want us to draw some various things. So 2A is the same thing as A plus A, right? A plus A is 2A. So let's draw 2 of those, head to tail. 1, 2, 3, so it's 4. 1, 2, 3, 4. There's the first A. And then 1, 2, 3, 4. There is the second A. This entire vector is 2A. All right, for this one, 2B, same situation. I'm going to add B to another B, and the entire vector all the way from top to bottom is 2B. All right, 3/2 B, that's 1.5 B's. So here's 1B plus 1/2 of a B. Let me change that. The green's really hard to see. That would be 3/2 B. All right, let's take a look. 1/2 of an A, right? So it looks like at the start, this was, let's see, 1, 2, 3, 4 diagonals. So 1/2 of that is just going to be 2 diagonals. That's 1/2 of A. A plus B, again, this is where head plus tail comes in. So let me draw in A, 1, 2, 3, 4, and draw in B. So from the original tail to the final head, that is A plus B. A minus B is the same thing as A plus negative B. So let me draw in A, 1, 2, 3, 4. And then negative B, instead of going down, would go up. So if I can draw this as straight as I can, again, I apologize for no ruler. That is A minus B. All right, and then this last one tells me I should take half of A, which, oh look, it's right here. This is half of A, so I'll just start with that. Half of A, and I'm going to subtract 3 B's. Okay, I'm going to have to draw that half of A somewhere else. Maybe right here. Okay, if that's half of A. Now, subtracting 3B is the same thing as adding 3 negative B's. That looks awful. Hold on. Negative 3B is the same thing as negative B plus negative B plus negative B. Okay, so this is pointed downward. I'm going to have to go upward 3 times with that. 1, 2, 3. So from the original tail to the final head is the answer to that problem.